technical session shortly. Also, just to inform you, today we have our validatory function in hall number 4 starting from 1:30. I request you to please join us exactly at 1:30 in hall number 4. Thank you. Water Development Agency, Ministry of Jal Shakti and Water Digest. We extend a very warm welcome to all the dignitaries, speakers and delegates. We are fortunate to have today our chair and co-chairs with us. Professor A. A. Kazmi, Department of Civil Engineering, IIT Roorkee. After joining IIT Roorkee 2004, he is presently working there as a professor from 2014. He has received several national and international awards and published more than 200 papers in peer-reviewed journals and conferences. He is a member of several technical committees of various state ministers and National Green Tribunal. Our co-chair, Shri Ajay Gupta, member, Drainage Delhi Jal Board. Presently, he is working as a member of the Delhi Jal Board. He joined Delhi Jal Board in the year 1989 and worked there in different capacities, having an experience of more than 33 years. Shri Ajay Gupta is the technical head of the organization for sewage works in Delhi and is closely associated with various important projects related to the regeneration of river Yamuna. And we have with us our moderator, Anupama Mahod Sood. She has almost 18 years of experience in the environment sector, especially information, education and communication. She is heading the Water Digest magazine and has expanded the scope of magazine to create a platform where both government and private players can meet to discuss solution to the water problem that the country is facing. We request Mr. R.P. Singh, Deputy General Manager Jal, New Okhla Industrial Development Authority, our co-chair Shri Ajay Gupta, Member Drainage, Delhi Jal Board, and our chair Professor A. Kazmi, Department of Civil Engineering, IIT Roorkee, to kindly join us on the stage. Can we have a huge round of applause for our co-chair and chair? Thank you so much, sir, for joining us today for this session. Now, I would like to invite our moderator, Ms. Anupama Madok Sood, Director and Editor, Water Digest, to take their seat on the stage. Thank you so much, ma'am, for joining us. Now I request Ms. Anupama to please take it forward from here.
So, a very good morning, everyone, and Honorable Chair, Professor Kazmi, our co-chair, Shri A.K. Gupta ji, Member Drainage, Delhi Jal Board, Mr. R.P. Singh from Okhla Industrial Units, and all our speakers, other panelists who will be speaking during the day, and all the attendees. A very warm welcome to this particular session, which we have very thoughtfully planned, which is on recycle and reuse of wastewater for water resilience and water market. So, while we are all most from the water industry and are well aware about the basic challenges of the water sector, but just to set the tone for this particular seminar, I would like to talk about a few challenges which the industry is facing and why we need to talk about water security, which is the theme for this particular session, this particular India Water Week. So talking about the water security, there are a couple of challenges of the water sector and we all are aware of it, like increasing urbanization and industrialization, putting a lot of pressure on the existing water bodies, declining availability of water resources. As of now, whatever water availability was there somewhere in 1950 has reduced much to, you say, 1577, and will be much lower in the coming years if we'll keep, utilizing this resource the way we are utilizing, wasting our water resources. The basins are already closed. I'll not take much time. I'll just quickly come to the point that the need of the hour is that we kind of put in certain conservation measures and also utilize the available resources like available wastewater, which is no more wastage. It is reclaimed water, and we need to reuse it. Now, how do we use it? How do we reuse it? What are the possible interventions? What are the possible upcoming technologies or the policies which needs to be tweaked further, improved further, so that there will be a possibility of reusing it at a larger scale, so that the pressure on the available fresh water decreases. So with this, I hand it over to Honorable Chair to take the session forward. In the overall session, we have divided it into three segments. We'll have 2 paper presentations also in the initial hours itself. Then we have industry perspective, and we'll have a batch of almost 3 speakers who will be talking and sharing their perspective. Then we'll break for tea, and we'll resume again, and we'll have another batch of 3 speakers who will be talking about industrial experiences. And then at the end, we'll be open for the Q&A. So with this, thank you, sir, for accepting this, being the chair of this particular session, and I hand it over to you, sir.
Thank you very much, Ms. Anupma and Mr. R.P. Singh. I think Mr. Gupta, we are associated for a long time for Noida Authority, wastewater treatment plants, sewage treatment plants, also Delhi Jal Board mainly for the NGT committees and that Commonwealth Games MBR system. The main thing just I noticed regarding the reuse, like if we want to reuse the water, if we go for reverse osmosis, like this is technical, if we go for reverse osmosis, there will be no problem. And membrane systems. And once we want to reuse the water without reverse osmosis and without ultrafiltration or membrane bioreactor, we are facing a lot of problems. And then if we go for only filtration and then reuse, then we need some studies, really some case studies like where we really utilize the water and what are the qualities, and so that there will be no public problem or public nuisance, and from the gardener's perspective. Therefore, just here I want to say that we have to devise the policies very carefully. We have to put a lot of funds for the reuse. And it's not like that we just make the policy like Haryana or Delhi or somewhere. We must have the funds. Okay, we have to go for ultrafiltration, reverse osmosis, 20%, 30%, and this money should be kept for reuse. And we should know the inlet water quality. Like now we are facing in Mathura, the inlet water quality for RO is very bad, then RO choked very fast. Therefore, we have to have some kind of studies. Don't go very fast in a fast pace. Therefore, reuse very, very difficult task, only except for the horticulture. For other purpose, we require the reverse osmosis, and to maintain the reverse osmosis, we have to have better pre-treatment systems. This I notice in India many places, where we have the membrane bioreactors, okay, we can reuse it. Where we have the reverse osmosis, we can reuse for non-potable purpose, almost process, other things. But for others, we have to devise everything very carefully and very planned way, and we have to put many barriers so that in future it will be more sustainable and people want to take that kind of water. This is my experience. Therefore, all studies should be backed by very strong data. That is very, very important. Otherwise, we will face many failures for the reuse, and then we have to go for eyewash type of thing. Thank you very much. Then just I want to ask Mr. Gupta to share his experiences regarding the reuse of water in Delhi Jal Board, so that we can also improve our reuse systems.
Thank you, sir. Good morning, everyone here. First of all, I'd like to pay thanks to DG and NWDA to give me the opportunity to nominate co-chair for this seminar. And thanks, Anupma Madam, to organize this seminar, beautiful seminar. Since the topic is reuse and recycle of wastewater and water resilience and water market, topic is very relevant from DJB perspective. I have prepared a small presentation on it. Can you please go through it? Yeah. Next. some key profile of DJB has been prepared. Present population of Delhi is around 2.1 crore, and present water demand is 1260 MGD, and we used to supply only 990 MGD, and source of water the Upper Ganga Canal, Yamuna River, Ravi Bias, and groundwater. See, demand of water is 1260. We are having a deficit of 270 MGD right now. So population of Delhi is going to increase. As per Master Plan 2041, population will be 3 crore, and supply is going to increase 1,500 crore. So it's a big challenge. How to meet this water deficit is a big challenge. Next. What are the ground realities? Due to rapid urbanization, demand of water is increasing day by day. The most of water supply is available through surface water and groundwater, because these are only two sources available with all of us. Most of the states are having MOU for sharing agreement river water. See, as far as Delhi is concerned, we are having a share agreement with Yamuna River, with Himachal, UP and Haryana, and we are not going to increase water share in any case, but population increase day by day. So the demand of water is going to increase, but only thing is that we are putting load on extraction of groundwater. So extraction of water also increasing day by day, but due to rapid urbanization, groundwater recharge has become less and less day by day. So ultimately, the only option is left is that we have to utilize groundwater, this recycling of wastewater, so that the filter water demand could reduce. Because, and the use of filter water also become necessity to reduce the demand of filter water, as existing source of water already overstressed. Reuse of water will help in conserving natural water resources as well. And reuse of wastewater also reduce pollution of river load, because once you utilize the upstream of it, definitely load in the river also reduces. So DJB is working hard to reuse this treated effluent on various means. Say, here, the treated effluent coming to the STP, and STP effluent is discharged into the river, and this treated effluent also being used in the factory. We are using treated effluent to the power plant for cooling purposes. We are supplying treated water to the streams. We are supplying water to the farmhouse also. We are using treated water to recharge the artificial lakes, and through which we are going to extract this recharge water through tubes, and after RO we are going to supply to the area. So this is a whole cycle, and we are working on it, and various projects are also have been implemented based on this concept. These are a few facts. Right now, DJB is utilizing 90 MGD of STP, treated effluent on various purposes, and we have a plant utilized 267 of 225 MGD balance, because as per agreement of Yamuna River, we are used to supply 267 MGD as the environmental backflow to the river. And one more thing we are doing, that right now we have we are constructing 170 MGD STP at Okhla, and the entire treated effluent is being discharged to the Agra Canal for irrigation purpose. Now we are going to recharge into the river downstream of Okhla, so that river will be rejuvenated. So the utilization of treated effluent is much important and much necessary nowadays. DJB aims to promote use of treated effluent for non-potable purpose. DJB have installed filling points on each STP, so that treated effluent could be utilized. We have hold a seminar with different stakeholders, which are park owning agency, through which they can utilize our treated effluent to the horticulture purposes. And DJB also use to supply 260 MGD backflow to river Yamuna. This is the current scenario of Delhi. We are utilizing about 90 MGD of STP, 90 MGD of effluent. We are using this effluent to the golf course of Bhalaswa and Mehroli. We are using this water for the PPP plant of this Pragati power plant for cooling purpose. We are just supplying water for horticulture purpose as well to the IFCD. We are using the supply this treated effluent for the various purposes in DJB as well. We are supplying treated effluent to the Lodi Garden, to the Nehru Garden, Nehru Park also, to the Rashtrapati Bhavan also. So various methods have been, various mechanisms has been evolved to use the treated effluent for the various purposes. And one more important thing I will discuss, that we are going to construct 70 MGD of coronation tertiary plant. There is a 70 MGD STP already existing there. We are going to install a tertiary plant of 70 MGD. From there, we are going to create Class C water. And from there, we are going to discharge to the upstream of Palla. From there, it will mix with the raw water. Again, we will treat it and supply to the area. So treated effluent will be used as a source of raw water in near future. and tenders were already invited and we are in process of award. So this is the first kind of project we are initiating in Delhi. This is the first point I have discussed right now. And one more thing is that in DDA area, about 75 population is coming into near future in DDA land pooling area. So we have involved a master plan in DDA. We have made a provision that all land owning agency has to install a liquid waste discharge policy, so that they have to construct decentralized STP within their premises. They have to use TDO effluent for secondary purposes, for flushing, etc., etc. They are supposed to utilize the water for the horticulture purpose also. If excess water is there, then only they have to discharge into the stormwater for recharging water body. We are not going to lay any sewage system in this area. This is a new policy we are going to implement. This will reduce the demand of the filter water in the area. And one more thing that since STPs are going to upgrade on latest norms of NGT of 1010, so quality of effluent is going to be very good in near future. So we are using that TDO effluent for the construction purposes. For right now, we have a plan to ban all groundwater use for the construction purpose in near future. We are also supplying TDO effluent to irrigation purposes. We are supplying to the PPC for cooling purposes. We are creating water bodies to recharge groundwater and accession of groundwater through tube wells, and that water should be supplied to the area after RO plant. And one more thing is that we are supplying this TDO effluent for the farmhouses, because due to continuous accession of groundwater, the groundwater have been depleted. There is no water itself. So we have a plan to supply this water for the farmhouse as well. Recently, I have been to Israel and we have found that this is a water scarcity country, and hardly any river water is available, and it's surrounded with the sea. So groundwater is also limited availability. So they are using 90% of the water through desalination plants of seawater. See, just to understand the water crisis over there. And one best thing they are doing is they are treating the whole sewage, 100% sewage treatment is there, and they are utilizing 90% of the treated sewage for the irrigation purposes. See, so this thing has to be done in India also, because water is not going to increase. We have to increase utilization of treated effluent to reduce the demand. So as per the study conducted, by 2030, the demand of the supply, demand of the water is going to be 40%. So the topic is very relevant. Since various speakers have been invited, so definitely we are going to be educated from their experiences, and I will try to implement all these experiences to the DAB as well. Thank you very much.
Thank you very much, Mr. Gupta. Very enlightening presentation, but you have to be very careful for the operation maintenance of these wastewater treatment plants. And once operation maintenance good, then we can really have a successful models. Now I want to request Mr. R.P. Singh, Deputy General Manager, Noida Authority, to share his experiences regarding the reuse of wastewater in Noida.
Thank you, Kazmi sir. Welcome delegates, distinguished guests and other colleagues. Today is the day India Water Week has provided us the opportunity to explain our activities at the current topics, reuse and recycle of wastewater for water resilience. It's a very important topic for the environment effect, as well as at present the INGT and other apex court has directed to do the same on the most efficient manner. I am from Noida, working for Noida Authority, looking over the sewerage and jal, water supply all over Noida. Noida is having population near about 14 lakhs in current stage. Area, surrounding area is 50,500 acre. You can say 103 square meter is a periphery of that. As per current population, we are generating 325 MLD approximately sewerage per day. And we are having 411 MLD of capacity for the treatment. We have 8 sewerage treatment plant working on sequential batch reactor, which is most advanced technology in India now. We are providing 325 treated as, and near about per day 250 to 60 treated water, 260 MLD treated water generating per day, in which all the treated water having parameters like that, all CPCB norms, NGT norms, the treated water BOD approximately less than 10. Fecal coliform less than 100. We are having tertiary treatment plant also, so the treated water manner is a very efficient. That treated water up to 50 MLD we are using in our recycling purpose for irrigation of Noida area, green belts, parks. 10 to 12, 15 MLD we are selling in the market for the construction of building to the builders, as well as Noida authority is also using that in their construction projects. So this is more beneficial for us. In 2020-21 we have sold near about 17 lakhs of revenue we have collected. In 2020-21 we have collected 24 lakhs for the sale of the treated water. In 2020-23 we have till date sold near about 10 lakhs of treated water amount. The collateral benefit are lifting less groundwater from and saving resource, as well as we are using in irrigation, parks, green belts, major parks of the Noida area. We are providing 100% treated water for irrigation. And rest of the treated water we are flowing in Hindon River and Yamuna River, passing from both sides of Noida and generating e-flow in that. Maintaining greenery in all over situation. In future plans, we will introduce 100% of the treated water in Noida, major areas of the Greenbelt Parks sector, but it will take some time. And we want to make our city as a zero discharge. That will be more effective phenomena for future if we will become a zero discharge town. Noida, at present you are seeing that a more environment effect, having more hazardous atmosphere at present, above 400 AQI. So on such parameters, if we are going to adopt, we can reduce that. We are, at present, we are 100 to 150 tankers, our daily sprinkling that treated water on the plants and the trees and the greeneries of the Noida area, just to reduce the PM 2.5 and PM 10 daily. This is our perspective. In coming future, we want to introduce more and more. Our SBR are working very efficient manner. Professor Kazmi sir has also visited so many times in Noida area, and he guided us to make it more efficient and so that the benefits goes to the environment. Thank you.
Thank you very much, Mr. Singh, about the experiences. Just you are now mainly focusing on operation maintenance issues. I think if operation maintenance issues were resolved, we can utilize a lot of water in the Noida. Now I'm handing.
Thank you, sir, and thank you, Singh sir, for sharing your insight, like Kazmi sir has mentioned. So, with this, I think we have come to the end of this short inaugural, which we planned for this particular session as well. And I now request that maybe if you can take it over, and we'll have a memento for Mr. Singh, and we move on to the industry perspective further.
Thank you, Mr. R.P. Singh, for joining us here. And now I request our Chair, Dr. A. Kazmi, to please felicitate Mr. R.P. Singh with the present. Thank you once again, sir, for joining us today at this session. Now I invite our next three speakers for another panel discussion. Mr. Anshuman, Associate Director, Water Resources Division, TERI. Dr. Indra N. Mitra, Director, Technical and Project Development.
Perspective will start, so maybe
First, second. And then last my third. I gave you.
So I invite as speakers for the next panel discussion, Mr. Rajneesh Chopra, Global Head Business Development, VA Tech Wabag Limited, to please join us on the stage. Can we have a huge round of applause? I now invite Dr. Indra N. Mitra, Director, Technical and Project Development, Cambi India, to please join us on the stage. I now invite Mr. Arun Sharma, Senior Manager, Management Consulting Practice, PricewaterhouseCoopers India, to please join us on the stage. Thank you so much everyone for joining us, and I request Ms. Anupama to please take it ahead from here.
So before we start this industry perspective, I'll just reconfirm from my team, is Mr. Mitra joining us in a while? Okay, so by the time Mr. Mitra joins us, I'll just say, like, you know, in the initial part of the program, when we just started it with the inaugural session, I mentioned that, you know, we will be looking forward to the industrial industry perspective as far as the technological interventions are concerned. So we are glad to have with us, three speakers who will be presenting the industry perspective, the kind of technological interventions they have come up with. Maybe they'll be talking about their case studies. So I leave it to the respective speakers to either present it through a presentation or they can even speak about it. But please restrict your presentations and speaking slot to 8 minutes. I'll flag you when it will be 7 minutes, but then we make it 8 minutes. So maybe I request Rajneesh ji to kindly take it forward. And Kazmi sir, for your feedback at the end of the session.
Thank you.
A very good morning to everybody present here and the distinguished chair and co-chair. Now today I'm going to talk about recycle and reuse for environmental sustainability and commercial viability. I think there are a lot of planners here, there are a lot of policy makers here. We are more on the practicing side. So what we do is that we implement a lot of projects, not only in India, but we have implemented these projects across 30 countries globally. And we are going to share some of our experiences, which we feel are very much doable. And we have implemented same kind of projects, which can be scaled up within the country. Now, we all know that, India is also a signatory to Sustainable Developmental Goals. And so water is very essential. I think this is not something new I'm going to talk about. I think water is central to all the SDG 6. Water, air and food are the three major things on which our survival depends. But we feel that SDG 6 has direct correlation with certain SDG 6, other SDGs, which is 3, 14, 7, 9, 11, SDG 13, 15 and 17. Now, our endeavor has been to see that, whatever projects we implement going forward, how do we keep all these in mind and we devise those projects. I think I'll start with one of our projects, which is got a capacity of 110 MLD. This project is in Chennai in India. It is not something new. We did it around 1.5 decades back. I think it has been a case study which has been spoken in a lot of international forums. Now, over a period of 14 years, more than 98% of the energy, captive energy required to run this plant has been produced by the plant itself. Now that is something which has led to a lot of reduction in GHG emissions. This takes care of almost more than 60% of the OPEX. And we find, based on our experience, one of the challenges has been that there are a lot of projects which are funded by the central government, which are funded by the multilaterals, but when it comes to OPEX, I think there is always a stress. So this actually takes care of majority of your OPEX. Then in this particular plant, we have arrangement where our client, Chennai Metro Water Board, they have been selling 24 MLD of water to CPCL, which is a refinery there. In the same refinery, we built a reclamation plant where 16 to 18 MLD of the water is processed and is used for non-potable purposes within the refinery. Now, since it was done 15 years back, for the sludge portion, we have typical sludge drying beds. But what I want to highlight here is even 15 years back, this sludge was not going waste. The farmers would come with their trolleys and tractors, all dried sludge they will take and use it as a manure in their farms. So it was being used. So all the three components had a value. And going forward, probably we have to enhance this value both for the commercial purposes as well as environmental stability. Now, I think Professor Kazmi was mentioning about the RO. Maybe it is a must. So I think Chennai again has been a leader there. We have built a 45 million liters per day recycle reuse plant. This has UFRO, and finally the disinfection is done for ozonation purposes. This was funded under the Amrut by the central government, and it is running very successfully. What I want to highlight here is our client will recover their money in 5 to 7 years. Originally they thought they will be able to recover in 3 to 4 years, but a lot of industries were shut for 2 years, which they could not supply the water because of the COVID situation. So it has a lot of commercial viability also. And the plant life cycle is 25 years, so it's going to continuously churn the revenue for the water board. Now, here I'll just like to mention that there are a lot of dignitaries, both from the central government, overseas, who have visited this plant. I have personally been there so many times. This water is not being used for potable purposes. But I have no hesitation in drinking that water, because normally I drink, indirect potable reuse water, which is given to me. Here I am getting, probably the best possible water. Also, I would like to highlight here is, based on a comment which came from Professor Kazmi, that we have built a non-RO potable reuse, direct potable reuse in Namibia. Probably if you have any time, you should visit that. It's been running very successfully since 2003, much before even Singapore came up with that plant. So it has been running very successfully. It's a 12-stage multi-barrier system. And I will be very happy to share the details. I'm not carrying it in the current presentation. Now, I think member drainage is here. We have built one plant in Pappankala for Delhi Jal Board. So what I just now mentioned about Kodangur in Chennai, that was 15 years back. But today, the scenario has changed. This plant is designed on less than 10 BOD and less than 10 TSS. There is a captive energy of 2.8 megawatt to be generated here. And the sludge, there is a system which has been imported where all the sludge, the dried sludge, will be mixed with organic material and converted into biomanure. Automatic bagging will be done and it will be distributed free to the farmers. So here again, a lot of components, both the power and the sludge, all three. The water, DJB, as he has already mentioned, they are using it for various purposes, and they are also created a lake where they are taking the excess water, which in my opinion is a very, very progressive feature which has been implemented by DJB. Now, if I look at all our plants which we have built, so we generate around 31 megawatts of energy every day. And if you look at, it has got, 48 lakhs and 36,000 savings on electricity per day from these plants. And we have reduced the GHG emissions by 5,58,100 tons through this electricity. So that's something which earlier was not being monitored. So now we are monitoring in every plant how we move towards decarbonization and how we are going to reduce the GHG emissions. So going forward, this is something which we have done. Now I hope that we are able to implement first in India before we implement it overseas. So we are going to convert into biogas, which will give a much better, commercial revenue. And it can be sold in the open market, which is again a green fuel. And we plan to, use treated water for generation of green hydrogen. And if some of our, dialogues are successful, which we are currently having with various jal boards, we'll be able to generate hydrogen, take the oxygen for aeration. I think we have very learned people here. They can understand that if I pure oxygen, I feed to aeration, 60% of the energy factor I'll be able to reduce in an STP, and which will give me savings, at the same time a lot of commercial revenue to our customers. So this is something which we intend to implement very soon. We are in dialogue with people both in Middle East and in India, and you will see this happening over the next 12 to 18 months. Thank you so much for your attention.
Thank you, Mr. Chopra, for a nice presentation. Just I want to suggest Mr. Gupta also, once we want to plan for the potable reuse, after reverse osmosis, we have to go for advanced oxidation process. I have seen this advanced oxidation, even though for indirect reuse, just after mixing it to the lake, because there are many micropollutants are there. Therefore, I have seen in South Africa, and maybe Indra can say in America also, not only RO, after RO, if you want to go for potable reuse, for industrial use, RO is okay enough. So for this is just my suggestion. Therefore, we have seen a long studies in Cape Town and other places where we are facing these kind of things, and they are mixing the treated, tertiary treated water, even after RO, and then they use UV or chlorine or maybe ozonation or something, and then they add for drinking. Because drinking, anybody can, you can put allegation or something like that. Therefore, you are very, very careful. Yes.
So we have already planned, as you suggested, sir. After mixing the raw water, again we are, whole raw water will be treated at a WTP. Yeah. After chlorination, then only we supply, not directly.
Yeah, even though,
yeah.
No, it's okay. Even though after treatment you require that advance.
Yes,
just
that will be done.
These kind of
yeah.
Because WTP is conventional.
Yes.
And then I asked, yeah.
So now I request and move on to our next speaker, Dr. Indra N. Mitra, Director Technical and Project Development, Cambi Limited, Cambi, India. And Mitra ji, I request that we would like to restrict the time slot to 8 minutes. I'll give you a slip at 1 and then flag you, 7 minutes. After 7 minutes, I'll give you a flag, that 1 minute left, okay? Yeah. You want to present it? You want to speak? You already have your presentation loaded? Is it already there? Yeah, please go ahead. So I wish that, the participants who are sitting here, you can make it interactive at the later stage, and if the time doesn't permit, I'll suggest that will be done during the tea break, which will be around 10:50, I guess. 10:50 or 55. Over to you, Mitra ji.
Thank you. Good morning, everybody. Good morning, distinguished guests. Today, I'll be talking on sewage treatment plants as resource recovery center. As you know, sewage treatment plants receives wastewater from cities and towns and has a lot of resources in there, which we want to recover. So, next slide, please. I'll start my topic with a quote from Chris Piot, Director of Resource Recovery of DC Water. There is no such thing as waste, only wasted resources. So that is what is our motto. What happened? Which way? Next. So what is today's trend in sewage treatment plant? As you know, many utilities around the world are recovering resources from sewage treatment plants because there are a lot of resources in the sewage treatment plants. This is nothing but waste to wealth, promoting circular economy. And today's sewage treatment plants are being renamed as Water Resource Recovery Facility. Next. So what are the resources in STPs? First is wastewater, obviously, treated wastewater. It's a resource and you can recycle and reuse it for various purposes to meet your water demand. Second, most important is the sludge, and two things you can get out of sludge is basically sludge to energy using anaerobic digestion and advanced anaerobic digestion. And the second one is sludge to fertilizer or soil conditioner or amendment. Because it's a source of carbon, nitrogen, phosphorus using again anaerobic digestion and advanced anaerobic digestion. Then there are other sources like you can recover phosphorus. Remember, we import phosphorus in India, so there is a huge resource of phosphorus. If we recover, our import bill will reduce. Centrate from the treatment system can be used in agriculture, and there are other various things that you can recover from sewage sludge. Next, please. So we are going to talk mainly two main things, wastewater and sludge. So first is treated wastewater, recycle and reuse. Next. So first of all, when we have a wastewater, what are the applications? Where can we use this wastewater? Mainly, if you see, first is the community reuse, means in your parks, fields, landscape, you have to first define what is your purpose of using the wastewater, the application. Agricultural use, for irrigation, impoundments and recreational, for fishing, boating and swimming, environmental reuse, to augment some streams, and industrial reuse, groundwater recharge, and all these are non-potable uses. Okay, and the last one comes potable reuse. So for each use, there should be a criteria to meet. And what are those criteria is listed here. We call the grade A, B, and C water. So grade A, grade C is the most stringent one. Grade A is the least stringent one. And you can see the BOD, grade A is the most stringent one, sorry. BOD is 30, COD 150, turbidity, TSS 30, and total nitrogen, total phosphorus, all those values are there. So for each type of use, you have to select which grade you want to treat it, because your treatment technology will be based on that. Next, please. Now, if you look at today's discharge limits that has been imposed by NGT and has been all sewage treatment plants in India, if you can see BOD, we are required to go to 10, TSS 20, COD 50, total nitrogen 10, total phosphorus 1, and fecal coliform 230. So you can see, except for TSS, we have already reached the recycle limit. So it meets basically the grade C. It is better than grade C water that we discussed, and it's almost equal to grade B. So most of the water that we treat today or will be treating to meet these limits will be of recycle and reuse category, except for the TSS. Next, please. So this is the list. You can see community agriculture. This is the type of application we discussed and what kind of reclaimed water quality we require. grade B, C, or A, and you can see unrestricted and restricted. Unrestricted means the water can, can come in contact with human beings or animals or anything. Restricted means the water body is fenced, so people cannot come in contact. So obviously restricted will have a lesser strict requirement than unrestricted. Next, please. So again, this is the same thing. I'm not repeating here. For different uses, what are the processes you have to answer, and this is the treatment technology that you need to put in. So treatment technology for grade A will be treatment A, grade B will be treatment B, and grade C will be treatment C. Next, please. Going a little fast because time is short. Next, please. So this is the treatment technology that you can see, treatment A, B, and C. You can see the most of the treatment systems remains the same. Additional requirement is required, treatment is required where you go for treatment A. But pretty much the treatment units remain same, maybe, for dosage and all those things may be a little different, but the basic treatment units remains the same. Next, please. Next, we are going to talk about sludge, energy and fertilizer as we discussed from sludge. Next, please. This is, you can see what is sludge. Sludge, when we when we process sludge, we do not call it sludge, we call it biosolids because it is a resource. So as you can see, biosolids has lot of organic matter, nutrients and beneficial microbes which can be recovered as fertilizer or soil conditioner, and also energy. About 9.3 million BTU per metric ton of biosolids is available through anaerobic digestion. Next, please. You see the soil conditions all over the world. The red ones you can see in India. The soil conditions are very bad in India because of the red, because the carbon content of the soil is very, very low. So we can use this sludge to basically augment the health of the soil. So as a soil conditioner, we can use the sludge. Next, please. Now, if you can see, the sludge comes into the digester and various uses. The biogas, which contains methane, can be used for energy, and two ways. One is basically you can just clean the methane and use it as a natural gas, or you can just generate electricity, and the digested can be shipped off and you can use it as a fertilizer. Next, please. So anaerobic digestion converts sludge to energy. Anaerobic digestion is the most common technology used. But today's trend is going for advanced anaerobic digestion using thermal hydrolysis process. It acts as a booster. It increases the energy production of anaerobic digesters and reduces the digester volume and produces a very high quality US EPA class A, which can be used as a fertilizer or a soil amendment. So the trend is going towards advanced anaerobic digestion. Next, please. So this is the diagram. You can see the thermal hydrolysis process is just placed before the digester, and the volume of the digesters is reduced by 60%. Next, please. Next. You can see here the digester, the sludge applied by DC water, one with chemical fertilizer, another with biosolids. You can see the difference. What is the quality? Next, please. They are using the product and selling it under a brand name called Bloom in Washington, D.C. wastewater treatment plant. Next, please. And I think, and if you have any questions, I'll be happy to answer.
Thank you very much, Mr. Mitra.
Okay.
Actually, very nice presentation. And you discussed about the policy, and basically you are involved with the thermal hydrolysis pretreatment and for improving the quality of the sludge as well as improvement in the quantity of biogas. I think we should put some of your plant in India. And now I'm handing over to Ms. Anupma.
Thank you, Elsie sir, and thank you, Mitra ji, for this wonderful presentation and also, taking care of the time slots. So now we move ahead to our next speaker, Mr. Arun Sharma, Senior Manager, Management Consulting Practice, PricewaterhouseCoopers, India. So again, just to flag you, 8 minutes,
Yeah.
given to you.
It's more
Yeah,
than
over to
enough,
you.
actually.
Over to you.
I would be short. A very good morning to the chair, co-chair, and all the fellow speakers and all the participants. First of all, I would like to congratulate the organizing team to have this amazing mix of the speakers. I think what I could see, I mean, how I can say like all the pillars into this industry. So all are been here from the research perspective, from the think tank, Professor Kazmi is there. From the government side, Mr. Gupta, Mr. Ajay Gupta is there, and from the technical aspects, means what you see, what all sort of means the persons who have worked in a lot of technologies. Dr. Mitra is there, and from industry, I think the VA Tech, we all know means all sort of things they are been doing. What all first they have done in India. So. I was a bit skeptical actually to what I should cover in this presentation or not, because all the prominent speakers are actually before me, and more or less I was thinking that everything would be covered before I come here. So still, so that's why I could not make a presentation. I just kept it open. So here I would actually, sir, briefly I would like to put some points. What actually, what are actually the problems which are there in terms of project structuring in the wastewater management, in the reuse of all these things. As we all have seen in the recent years, the government of India and most of the state government are also looking a very keen interest in reusing the wastewater. As we have seen in the AMRUT 2 guidelines, the guideline specifies that the cities have to actually provide the water of their citizens at least 20% by reusing the wastewater, and for the industrial need they have to fulfill at least 40% of that demand by the reuse of wastewater. As per the World Bank report, I think it was a report published in somewhere in around 2015. The water availability per capita in India was around 5,000 cubic meter per year per person in the year 1950, which has drastically reduced. I think in 2020 it has reached to somewhere around 1,200 cubic meter per capita per year. So the water availability is getting very reduced. Means obviously there are n number of reasons. The population is getting increased. I mean the industrial requirements are actually increasing day by day. But yes, again we have certain other resources. The resource actually, the augmentation of resource again itself is a challenge. Let's take the example of Delhi. Delhi is already, I mean Delhi has already reached to their threshold, I think, before many decades. So already means we are very much crunched for the water availability. The groundwater depletion is there all across the country. We have seen various states. Obviously, I can't name those states. You must be knowing. There are various states in our country who are actually exploiting the groundwater, and they have reached to such an aquifer where the contamination, radioactive contamination is there. Some of the state, I mean, one of the state I know in the North India, I think they have certain rise in the cancer cases by 12% within 4 or 5 years once they actually reach to that aquifer, I think beyond 50 feet. So this sort of problems are there. Ultimately, the groundwater exploitation is actually happening. So at one place, if we can tap, the first challenge for the reuse is the tapping of wastewater. Whatever wastewater is being generated across the cities, that is lost. That is not tapped, that is leaked out. Means if we are assuming, even if we are designing as a consultant, means whatever projects we are doing, whatever feasibility reports we are making, at some point of time they tend to fail, or they are near to fail, because the tapping is not there, proper tapping of wastewater is not there. So these are certain areas. Yes, government is actually doing a lot now. I mean, the AMRUT guidelines are there, AMRUT policy, AMRUT funding is there. Many of the projects are there which have been taken shape in the past 5 to 6 years. The SBM is there. SBM is also focusing on the sewerage management across the small cities. So now the challenges actually now sir, technical things. Obviously, I have very prominent speaker, very knowledgeable persons here. So I would not take anything about the technical things. So I would talk about the project structuring things. So we have seen certain challenges in the project structuring. Projects have been designed and they are actually taking shape in the implementation. But what is happening at the time of implementation or at the time of the operation and maintenance of those projects? Certain things become so critical, and these are the problems which are not solved, and the projects are actually told as they are a failure. Technically, we don't have any issue. We have in-house capability in our country. We have many innovations. technically, I don't think that we have a limitation over the capabilities that we can't actually treat the water to the potable limits or even for the drinking purpose, as Mr. Rajneesh told, that the water, whatever is being treated, that is as good as the drinking water, which we can see. But the problem is the project structuring. The financial structuring is again a challenge. One big thing is there in all these sort of projects, the interest and the participation of private sector is very important, because more or less these are the projects which are even at the planning stage, also at the government level, at the central government or state government level, we see that these projects are actually being designed towards PPP models, because we assume that PPP is not something that we require financial support from the private sector, but we require the technical support and the operation and maintenance efficiency. That's why actually the government is planning to have all these projects on the PPP mode. But the limitation is just because there are limited financial viabilities which are there. But again, there are certain other instruments which are already available, but which have not been explored. Let's take one scheme of Central Government of India, Department of Economic Affairs came up with a scheme of viability gap funding scheme in 2006. So because I did some study in 2018, at that time around 60 projects were there which were having viability gap funding support, and out of those 60 projects, only one project was there, and that too was in the water sector for some Odisha project, which was actually getting benefit of that VGF scheme. In 2021, government has revamped that scheme, and now the VGF scheme is providing the financial support of up to 30% in the sewerage sector. But again, the challenge is that the states and the other departments, other bodies are not coming up with some projects, some proposals to the government of India, which could be actually used, for the VGF support. So financial instruments are there. We need to explore actually them, how we can actually utilize those VGF support things. So I will quickly actually go through the challenges, challenges which are, only 1 minute, sorry. So the challenges means what we have seen, the private sector participation is limited, the financial challenges are there. Then some knowledge base is not available with us, means like the model RFP documents, because there are various ULBs which are having very limited capacity, which cannot actually put up very good RFP, good concession agreements. So if we can, already Niti Aayog is working on some model concession agreement, but still I would, I would suggest some of us actually, even the private sector, from your way, I would request, all the private sector are also very much welcome. Nowadays, I have worked with a lot of government departments, and I have seen the government is very much welcoming to all the suggestions from the private sector. If we have certain good ideas, then government is actually accommodating them very easily. So again, one additional thing, the institutional support is also requested, sir, because there is a limited capacity across the ULBs as well as in the private sector also for the implementation. So we have various good courses, various good academic approaches across our institution, but still there are not very much good, very much good courses at the graduation level, which we can actually see where the people are actually being trained specifically for the water, wastewater and seawater desalination sort of projects. So I will quickly read out the 5-6 recommendations, sir, which I would be requesting from your model, but only 5 minutes, only 30 seconds, ma'am. So first is the model concession agreement work, sir, then project structuring innovative models, then dedicated financial support, and we can institutionalize the financial support also, how we can actually institute, because there are various lenders which are actually willing to support, but they don't have a mean actually to provide this financial support. Then technical technology is not a challenge. I don't think that technical technology is a challenge. Then equitable risk management, sir. If you allow me, ma'am, one quick example I would like to take, sir.
Other speakers lined up, so maybe
over the
tea you can discuss.
Just a minute, sir. For DJB, sir is there. I would just request, sir, because I have seen a challenge. What happened, sir? Let me close it. So what happened around, I think 10 years back, I was working on some project of a metro city. So there was a big STP of 140 MLD plant. And there was obviously, if STP is there, then sludge generation would be there. So what happened, the client mentioned that the sludge handling would be the responsibility of the private player. See, sir, and then the documents itself mention that we have certain penalties if you are not going to do this and that. Penalties are not a mode of actually project management. They are actually a mode of project control only. So penalties are not actually what happens in certain situation, because in that metro, there was not enough space to manage that sludge. So what will be happening? Good players will not come. Any aggressive player would code the project, they will get the job, and your project will get destroyed. So the project structuring, I would request at the government level, sir, this is a very important area which actually we need to accommodate, and risk sharing is very important in this particular sector. Many thanks for extension. Thank you so much, sir.
Thank you very much. I think this is very important aspect. People, I think government is taking care of these kind of risk-related problems. I think.
In the future, we are taking care of all these things.
Already taking the expenses.
So, thank you, Arunji. I'm sure there must be a lot of other things which you would like to convey. So, maybe I'll suggest that during the tea break or the lunch break, let's do that. So, as thankfully with the support of other speakers as well, we are on time. So, there is also a paper presentation by Mr. Prashant Sharma, who is the founder of Positive Action for Child and Earth Foundation India. And he'll be talking about grey water recycling solutions using nature-based filters, challenges for bulk producers in urban areas, and impact of it on recycle and reuse further. So Prashant ji, I also request you that please restrict your timings to 7 minutes, as if the time permits, we would like to take 3 questions at the end of the session as well.
Sure, ma'am.
Yeah.
Thank you so much.
Thank you.
A warm good morning to everyone in this room. My name is Prashant Sharma, and I run an NGO by the name Positive Action for Child and Earth Foundation, which is focused on accelerating a circular water economy through grey water recycling using natural materials. So the topic that I'll be talking on today is grey water management and how it can contribute to water resilience. So water is the most important issue of this century. I'm sure everybody in this room will agree with me. Without clean water, education cannot thrive, gender inequality grows, economic activity becomes stagnant, and development is stifled. In fact, if the current water scarcity in India continues, it is estimated that India would lose about 6% of its GDP over the next 8 to 10 years. And in many ways, the worst impacts of climate change are being felt through water only, because of prolonging droughts and intensifying floods. And unless urgent action is taken to rectify climate change, there will be worsening impacts in the coming years. So there are several definitions available about water resilience, but the easiest one and the simplest one is being water resilient basically means having normal supply of water even during disruptive events like earthquakes, floods, droughts, and other natural disasters. So there are several strategies available to build water resilience. Some of them are water conservation, so every drop counts. We have to conserve whatever water we have, and one of the best ways to conserve is to install smart meters, because smart meters store historical data. They also tell you where the water is being used, where the water is leaking, and in real time, which can help you in plugging those leakages and save water at the same time. Then the second one is water optimization. So water optimization, again, it I feel is the lowest hanging fruit, because just by installing water efficient plumbing fixtures, we can increase the efficiency of the water that we currently use. So as an example, having high efficiency toilets, waterless urinals, and low flow aerator taps. Then we also need to include groundwater and recycled water as part of revenue water. Currently, groundwater is just considered as a supplementary source of water, but it needs to be part of revenue water. And then direct supply through water tankers should be restricted only for emergency use. Education and water literacy is one very important issue. People need to be made more water literate. And the thing is that we tend to believe that technology will solve a lot of problems, but in fact technology needs to be married to changes in human behavior and practice. For example, if you install an aerator which is highly water efficient, but if people don't turn off the tap, or let it run for longer, or if they don't complain about malfunctions in a timely fashion, then we are not going to save water there. Then it is also important to calculate the real cost of water and tell people about the real cost of water. That real cost of water would involve the cost of everything that has gone into getting the water to the point of consumption, the cost to dispose of that water, and also the cost impact of the business to the business if access to that water is lost. The other crucial component that we also have to look at is to reduce the carbon emissions at each stage of the water's life cycle, from the materials and energy we use to abstract, store, transport, treat and recycle water. Then water neutrality is again a buzzword over the last few years. So water neutrality concept is basically that the total demand for water within a planning area after development takes place should be the same or less than it was before work began. And grey water recycling and reuse offers tremendous potential in this regard. The next point is about stormwater management. Obviously, if the stormwater is managed well by using vegetative roofing, bioswales, detention ponds, rainwater capture, reverse wells, then we can all help the water to percolate slowly back into the water table and keep pollutants out of the water supply. So there are several challenges around the strategies available for water resilience, and I feel that one of the the biggest challenge seems to be that water is highly subsidized. It is inexpensive, so people don't feel the need to save something which is anyway cheap. Secondly, finding smart meters are expensive, so people don't want to spend that kind of money for something to save something that is very cheap. The other challenge that I see is around green cover. So on one end we've got the urban population which is growing, and on the other side we also have to increase the green cover to help mitigate the climate crisis. But getting green cover, increasing the green cover also gives rise to some pertinent questions as to from where will we find the water to water these green cover, because most of the time it's always groundwater that is used to water the plants. And as per a study done by World Bank about a decade ago, it was found, and not necessarily in India, but they did this study in Africa, but it kind of gives us some context. But in that study they found that less than 5% of water projects are visited after they are constructed, and less than 1% are monitored over the longer term. So something which is not monitored or maintained over the long term will not last. And then training and support. Communities where projects fail, water projects fail, are those where not sufficient training and support has been provided to the people. So we've got a very strong case for grey water recycling. It is very important to be good stewards of water, because access to usable water is a business continuity issue. This means that we have to value each and every drop. This means that we have to value each and every drop of water where possible, including all kinds of wastewater. And the best thing is that not all wastewater requires energy intensive treatment to ensure its reuse, and grey water is one of them. Grey water does not contain any fecal contamination or urine, so it contains only 1/10 of nitrogen that black water does, and significantly fewer pathogens. And also the organic content of grey water decomposes more rapidly than that of black water, and thus its treatment is easier. So there are several I wanted to go through all these slides, but I assume that the time is up, so I'll just skip those slides. But just quickly wanted to go through 4 options that are available for recycling grey water. So the first one is the simplest one, which is diversion. So this is basically just filtering the water and then reusing it. the second one is physical, where just filtering the water is not sufficient. You also have to treat the water using chlorine or ultraviolet rays or ozonation. The third one is biological, where you have to use an aerobic environment to treat the water and then use it. And then the last one, which is my favorite, personal favorite, is constructed wetlands, which can be used to recycle and grey water. The main reason being that it is sustainable. It requires low operation and maintenance cost, and they are efficient, effective, and also scalable. And the best part is that they use natural filter materials to filter out the contaminants in grey water. So this is how the constructed wetland would look. I'll just skip the challenges, but just as parting comments, I would just like to state that in addition to water conservation and water optimization, we also have to look for new sources of water. And grey water seems to be the biggest opportunity, in front of us, because it's the least dirty water and it requires less energy and less technology, least amount of technology to recycle. There are already several reuse options available to use the grey water as service water. We have to push for water circularity, and the challenge, I think, one of the main challenges in front of us is that water distribution and sewage management infrastructure design needs to be upgraded, dual piping needs to be got in, and old and creaking infrastructure needs to be upgraded. So in the end, I would just like to say that water is life, and we all need to reduce, reuse, and respect water. Thank you so much.
Thank you, Prashant ji. So, with this, I think we have come to the end of this particular part of the overall session. So,
thank you so much to all our esteemed speakers for this panel discussion. It was indeed an insightful session. I now request all the dignitaries to please present the mementos to our speakers. Mr. Rajneesh Chopra. I request all the dignitaries to please felicitate Mr. Rajneesh Chopra. I now request the dignitaries to please felicitate Dr. Indra N. Mitra. I now request the dignitaries to please present the memento to Mr. Arun Sharma. I now request Mr. Prashant Sharma to please come up on the stage, and I request the dignitaries to please felicitate Mr. Prashant Sharma. Sir, I request everyone to please stay on the stage for a group photograph. So we'll be taking a short break and we'll resume our last session for the day at exactly 11:15. So I request everyone to please be seated by 11:15 in the hall 2C. We'll be taking a quick break for 10 minutes and I request you to please be seated by 11:15. We'll be starting exactly at 11:15.
Yeah, so just to echo, that the tea break is I think from 10:55 to 11:20, the official timing. However, I request everyone, because of the paucity of time, we would like to start early, and so that's why, just to be on time, I request everyone to kindly resume at 11:10. 11:10, because we are going to start right at 11:15, and there are wonderful presentations by speakers from other industries. They'll be sharing technological interventions further. So continue participating, and then we'll see if at the end, sir, we'll have time. We'll also have an interactive session with the participants. Okay, thank you so much. We look forward to meeting you all at 11:15.
the day on reuse and recycle of wastewater for water resilience and water market. We have with us on our stage our Chair Professor A. Kazmi, Department of Civil Engineering, IIT Roorkee, our Co-Chair Shri Ajay Gupta, Member Drainage, Delhi Jal Board, and our moderator Ms. Anupama Modak Sood, Director and Editor, Water Digest. For our next panel discussion, I would now like to invite our speakers, our panelists, Mr. Manish Gandhi, Associate Vice President, Aeon Exchange India Limited, to please come up on the stage. Can we have a huge round of applause for Mr. Manish Gandhi? I request Mr. Anshuman, Associate Director, Water Resources Division, TERI, to please join us on the stage. I now request Mr. Sandeep Modak, Technical Head, India Sub-Region, DuPont Water Solutions, to please join us on the stage. Lastly, I would like to invite Mr. Mo Tiang Liang, Deputy Director, Industry and Technology Collaboration Department, Singapore. Can we have a huge round of applause for all our dignitaries on the stage? Thank you so much.
Continuing the rich deliberations, I think we would like to start with the first presentation of this particular session. And I would like to invite Mr. Anshuman, Associate Director, Water Resources Division, TERI, for your presentation. And Anshuman ji will be talking about water and wastewater management, integrating technological solutions and innovations. So before our speakers take it up further, I request that individual speakers, we have allotted 8 minutes. So you'll be getting a slip at 7 o'clock, sir. So when it is 7 minutes, we'll just flag it to you. So 8 minutes.
I just hope the PPT gets uploaded by that time. Firstly, am I audible? Thank you, Chair and Co-Chair, and also Water Digest for this opportunity. Friends, what we have been looking at, all this while in the India Water Week is looking into various perspectives of how we can improve the water use efficiency in different sectors. I think what we are going to focus on today is the wastewater. Time is very less, unfortunately, so I will not be able to go into too much detail. But what I want to emphasize right away is that we need to change the narrative of wastewater management. Now, there was time when we were wanting to look into wastewater management more from the perspective of catching and collecting and treatment, which still is to be done because a lot of gap is still there. But I think what we want to move beyond in terms of planning with the future is looking into the recycle, reuse and resources recovery perspective. So that's something that I want to highlight in today's discussion. It's a dichotomy how we behave with the water. At one hand we worship it, on the other we continue to waste. A lot of reports have been telling from time that what is being generated in terms of domestic wastewater, we have not been able to collect and treat them fully. As latest as 21 CPCB report tells us that at best what we are able to treat in terms of all the capacities that we have generated is around 28-29% of the wastewater sewage generated across the cities. Delhi around 72%, many other cities far less, UP, Rajasthan, if you look into 15%, 15%, Haryana, Punjab, better, but it's still lagging in terms of complete treatment. The point is all this wastewater which actually goes partially treated or untreated continues to give us the challenge of wastewater pollution across the board in river water bodies. Again, I'm not going to go into details, all of you probably very well know that. But what I want to highlight is the fact that we want to move towards not just treatment and collection, which is very important perspective, but look at it as a resource rather than as a waste. And that's where I want to give you some examples and share with you the possibilities through innovation and technological perspective that are there. Now in today's time, and I'm very glad that we have at panel, industry leaders who are very much into this business as well on providing the technology. In today's time, you have the technologies which can not only just treat the wastewater to the desired level of required regulations, but also give you a fair bit of resource recovery and as well as generate energy. As much as that you can basically treat the wastewater to the quality of drinking water as well. But of course, the perspective or the point would be that we have to take care that this entire process is smooth at a scale where it matters. It is very technically sound, and the relevant risk guidelines are basically followed. I just want to share with you some of our examples, and those examples which already exist. I mean, most of you probably even have heard about it. Chennai Metro, CPCL, MFL in Chennai, RCF in Mumbai, and many others actually are already, reusing using the treated wastewater from the municipal corporations in the near vicinity cities. And that's quite an example that we want to look across in a very, upscaled manner across the country. And this is something that we should be aspiring for. Now, we have done a lot of audits on various industrial sectors. I'll choose to give some of them as an example. Power plants, for example. I'll come to this in more detail. Pulp and paper, textile. Now, in the power plant that we have audited, not going into details again, paucity of time, but the fact that they consume a significant volume of water in their operations in cooling system, ash handling system, and many others. Now, when we audited them, what we found was around 5 meter cube per megawatt of water consumption is what they were having. And we thought, let's look into what are the possibility of recycle and reuse. And I'm very happy to share that a significant amount, almost around 64,000 meter cube per day, around 18% of their intake water, was the amount of wastewater that was generated that was going untreated and basically discharged without any use. And mind you, some of you who know the quality of wastewater from power plants, it's actually quite, in a way, good in terms of the kind of salts and the TDS that it contains, 200, 250. So that kind of TDS you will need a treatment system to basically treat for and bring it to that level. Now we designed a treatment recycling system for them, and what you can see is around 64 MLD of water, around 23,719 million liters per year of water could be saved just by this recycling system. In the power sector. Now, I'm not going into details of the technological perspective, again, paucity of time, but what I want to highlight to you is that a significant 60 to 65% of water, fish water intake could be saved because of this. And by the way, in this particular case, it was also financially beneficial, saving of around 7 to 9 crores annually. And also the perspective of cost benefit many of us look into is for example, the payback in this particular case was less than 3 years. So if you look into the possibilities, I would say that there are enormous opportunities in various industrial sectors to look into the wastewater treatment, recycle and reuse. I want to give you another example of, Indian Railways, a lot of, water that is used in their washing aprons and various other uses. Basically, a significant portion of it actually goes as waste or overflows or, just kind of, leakage losses. Now, again, here we identified what are the kind of, possibilities of recycling and reusing the wastewater generated out of railways operation. And this is just an example of, Delhi. Again, not going into too much details of all the interventions, but just to highlight to you the perspective of, technological possibilities. So in this particular case, back then we looked into the MBR and biofiltration with recirculation reactor as two possible technologies, considering the constraints that they had on space and technological perspectives of recycle reuse. Just to give you a perspective, a good BOD removal efficiency and a good recovery rate of water was the consideration for both of them. Payback again was less than 4 years. Cost benefit wise, it was quite attractive, and I'm happy that the railways was able to take this forward. Now, just to tell you the perspective of how much saving was actually possible by this, almost around 30 to 50% of wastewater that could be recycled through these operation of wastewater recycling system operated in the railways. And there's enormous opportunity across the country if you look into the railways perspective as a sector. I'm very happy that it already started happening. Some examples are already there. Delhi is one of them, but also Pune recently looked into the recycling plant establishment. They are saving around 5 lakh liters per day of wastewater through recycling system in their platforms. The last thing that I want to share with you is about the perspective that I mentioned about resource recovery, and this is something that we want to look into as far as future management of wastewater is concerned. Something that we are doing through a project with the European consortium in 2 places in India, basically Delhi and Kanpur. There are a range of technology that we are basically implementing this, and I'm very happy Manish is here. We are partnering with them as well on one of the technologies, Endicos, which basically is about concentrating the domestic sewage with the organic waste of kitchen waste to basically improve the calorific value, and in the process not only treat the water and digest the high load, but also basically recover the energy and nutrients as well. But this is one of them. We have introduced self-forming dynamic MBR. This is a pseudo MBR in the sense that it forms a biological layer which basically filters the filters the pollutants. Likewise, polishing technologies like structured adsorbents, which actually has a very fast kinetics and removal of chromium and phosphate. Constricted wetland plus, which actually gives a very good recovery of heavy metals. Likewise, ozonation, photoactivated sludge. This is there in Barapula drain. If some of you is interested, you can have a look at it. It's already working over there. Basically, this is a high algal rate pond and activated sludge combined, which gives a good amount of ammonia removal. Likewise, clean blocks for nutrient removal and recovery. And so there are all these possibilities that I wanted to share with you. And in all of these technology, the energy consumption is quite low because you are not really using a aerator. And also the fact that the possibility of nutrient recovery and energy generation simultaneously is quite there. You might want to go through this website and have a look at these details. Anything that you would want to know later, I'll be very happy to tell. But what I want to also share with you that something that we have articulated in a policy brief is basically we need to have mainstreaming the governance of wastewater treatment, reuse and recycle and resources recovery in our country. And there are enough examples and availability of technology which can be looked into of application, customization, and the possibility of then looking into this in a larger scale application. And that's where the mass impact can come in. There are a number of examples. In Tamil Nadu, I mentioned about one of the CPCL. Chennai Metro is basically using the water, generating energy. Likewise, in Rithala in Delhi, there is an example of wastewater treatment and also generation of energy. Again, not going into those details, these are examples which are already there. I'll stop here, basically, the fact that, I wanted to highlight the fact that, again, I will reiterate the point that wastewater treatment, of course, has to be looked into. Of course, we have to improve the coverage of, or the collection of the wastewater. But in terms of future planning, we also need to look into the recycle, reuse, and resources recovery, which has a very good potential. And this is the message that I want to give through this particular discussion. Thank you for the time, and Chair, I'm sorry I have to rush through the slides, but if there are any questions, I'll be very happy to take them forward later. Thanks.
Thank you very much for your very good presentation. You have taken the real case study that really we need regarding the reuse. And I think you can recycle all the water from the station by treatment, or otherwise Gupta Sahab can provide one recycled water pipeline to the station, and then we can reuse that line, like in Singapore or others. Any plant near the railway station where you can provide 3 MLD or 4 MLD?
So New Delhi. New Delhi is hardly any. No. Okhla is just STP. Okhla. Then that can.
Thank you, Anshuman ji, for your presentation. And now we'll have our next speaker, Mr. Manish Gandhi, Senior Vice President, Ion Exchange India Limited. And Manish ji will be talking about recycling and ZLD. He's been with Ion Exchange and been representing a lot of wonderful case studies on our various forums. So over to you, Manish ji.
Yeah. Thank you, Anupma.
And we have an 8-minute time.
Yeah, okay. Respected Professor Kazmi, respected Gupta ji, other high dignitaries on the dais and August gathering, very good morning to all. It's indeed my pleasure to make presentation such an important forum on zero liquid discharge. Why we need zero liquid discharge? So it's a strategic wastewater management system that ensures that there will be no discharge of industrial water to the environment. So the objective is that to recycle it, reuse it, and recover it. So that's the main objective of the zero liquid discharge. What are the factors which motivate you to go for the zero liquid discharge? So it is water scarcity. So needless to mention about that, water is very finite now. It's very limitedly available to in our country. Second is water economics. it's again, water is become very expensive. Forget about North India. Otherwise, if for the south part or the western region, the water, raw water to the industries is very, very expensive, right? So it is like 80 rupees, 90 rupees per meter cube. So then it is very justifiable also that why we need recycling, reuse and environment regulations. Now I would like to talk about what are the technologies by which you can achieve zero liquid discharge. So this is thermal processes, reverse osmosis, electrodialysis, forward osmosis and membrane distillations. Out of all, the bottom three are on the evaluation stage. Still, you know, a lot of work is going on for the fine tuning of the technologies. So right now, the currently which is available in the country is the first one. So what ZLD means and implies, what is the total scheme? So when the effluent comes from the industries, what we do the pre-treatment first, then we do the biological process. Biological process means effluent treatment plant based on anaerobic or aerobic. Then finally the outlet water which comes out, we go for the tertiary treatment, then reverse osmosis, and after reverse osmosis, 1, 2, 3 stages, then we go for the evaporators, thermal evaporators, and that is a complete, makes the zero liquid discharge plant. Now, what are the benefits of ZLD? The first is, of course, water conservation, right? So, if suppose an industry needs 100 meter cube of the water, fresh water, for the running the processes, by ZLD, they decline to 7% only, or 8%. So, 90 to 93% is the recovery. Then it reduces the wastewater discharge. Of course, it will not go to the environment, it will not spoil the land or water sources. Third is to protect fresh water sources. We all are drinking water from where? From surfaces water, means rivers, groundwater, ponds. These are the water which we are drinking at home, right? So we need to make sure that this contamination is avoided. So if industries are going to discharge, then definitely all these things, vital sources will be contaminated. Then separation of solvents, and apart from that, environment regulations and permissions which can be easily taken. These are the benefits. So gentlemen, now you can see the first scheme, that is a conventional treatment. ये पुराने ज़माने में होता था, when you used to take raw water inlet, आप water treatment plant लगाते हैं, after that you go for the process, industry में जो भी, any kind of industries, there are 23 kind of industries, maybe refinery or petrochemicals or chemicals or pharma or maybe food and beverages. So it goes through the processes, after that effluent is generated, effluent goes to the ETP plant, and the treated effluent, which is based on MINAS specifications or Central Pollution Control Board specification, used to be discharged. No, this is not now allowed, this is obsolete. So what we do actually now is that when from the processes effluent comes out, we identify the process streams from where we can recover the process. Unke jo valuable products hain, we can recover those valuable products back so that they can use in the applications. And then we take it to the zero liquid discharge plant, ETP plant and all, and then recycle it, followed by reverse osmosis and then thermal evaporation. Now the final is thermal evaporation. So what we are doing is, we are changing the phase. From liquid phase, we are going to the solid phase now. So make sure not even a drop of water goes out of the industry. So these are like thermal evaporators based on TVR technology, thermal vapor recompression. This is mechanical MVR. So when you have to go for the ZLD plant, you need to identify which is the best thermal evaporators which suits your requirements. So again, there are a lot of technicalities which are required, and which are the main components. So calendaria, preheaters, vapor liquid separation, it's a thermodynamics, right? So now water treatment or recycling industries are, also offering thermodynamics products to make sure that you achieve ZLD in your premises. Now, what are the challenges? Now, if you are setting up an industry, and what are the challenges which you get, why you are hesitant in going for zero liquid discharge? So one of the reason is, I'll start from the bottom, that techno-economic contemplations are necessary. Like for each and every industry, you need to understand what are the wastewater characteristics and what is the quantum. Even if 5 textile industries are there, it is not necessary that all may have the same kind of ZLD plants. It all depends on the kind of dyes they are using, kind of organics they are using, different kind of processes they have in their premises, and then accordingly you have to design. Then other challenges is Every industry says, I want to recover maximum water from my wastewater. So why don't you design a system with 95% recovery? Then we have to go for the system to make sure that it should be more economical. Then technological shortcomings. When membranes are there and wastewater is there, so it be sensitive. So membrane should not get damaged. So these are the challenges. What are the drawbacks? One of the major drawbacks is capex and opex. That is one of the main hindrance because of which industries are not going for ZLD, or they are considering ZLD, but they are not taking the decision. Because uski jo operational cost aati hai, that is quite expensive. So I'll give you some small examples also. Another thing is solid waste. Ultimately, from liquid phase, you are converting to solid phase. So then solid waste can be hazardous and non-hazardous. So you have to go for the landfilling sites and all. And last but not least is, in a global competition, you have to ensure that, your products should be very competitive. So it has got impact on the price also, product also. Because ZLD agar plant chalayenge, so it has got certain OPEX. Now I'll just share, only 1 or 2 minutes. Yeah. So I'll just share a few examples very fast. So this is one of the very big ZLD plant at Panipat, at Indian Oil Corporation Refinery, right? This is a petrochemical complex. It's a Japanese plant in a joint venture with the IOC. These are the photographs of the plant. Why I'm showing these different plants is to build up the confidence. These plants are running from last 7 or 8 or 10 years, successfully. See, this plant is surrounded by only agricultural land, pure agricultural land, not even a drop of water is going out. These are the photographs of the plants. If you see top left, this is multiple effect evaporator. So we are recycling it. This is the analysis. COD, BODO values are so high. And then what is the final cost, capex of the ZLD plant, and how much is the per meter cube cost which is coming over there. Then Patanjali, this is one of the biggest F&B plant in the North India, and the biggest ZLD plant. The capacity is 5,000 meter cube per day capacity. And out of 5,000 meter cube per day capacity, the COD values goes as high as 8,500 or 9,000. And BOD goes as high as 3,000. So we are extracting anaerobic process. We are going for anaerobic process. We are generating biogas, producing power. Apart from that, we
Manish
are also
we need to.
So
we have
going
more
for the
speakers.
ZLD also. And last but not least is Kia Motors. Again, so all these examples of different industries, where these plants are running successfully, which makes sure that how ZLD is actually implementable. Thank you very much. Yeah.
Do you want to say? Yeah, thank you. Very nice presentation. I think the ZLD main is the main cost incurred for the reject management. I think you are using MVR, people were using MEE. Therefore, there are many things, but all are expensive affair, very expensive affair, and that's very difficult to manage, and because the cost is exorbitantly high. That's the thing. Anyway, we will discuss in the panel session about the cost related aspects.
So now I'll invite Mr. Sandeep Modak, Technical Lead, India Sub-Region DuPont Water Solutions, as our next speaker. And he'll be talking about wastewater treatment with the FortiLife RO membranes. Modak ji, 8 minutes, 7 minutes, you'll get a card from our side.
Very good morning to the chair, co-chair, my fellow delegates and participants over here. So we had several sessions earlier, and before me Mr. Manish Gandhi has also talked about ZLD thing. So for wastewater treatment, as we go to the ZLD part, then you require very good technologies, or you require the membranes which can withstand very high TDS, high COD and other things. So I come from the component provider technology company, and so where do we play in this wastewater treatment? So you have this scheme in front of you. In the secondary treatment, we have the MBR and MABR, and when you proceed to the wastewater treatment, then you will have several other technologies like ultrafiltration. Then you have RO1. If it is for only a wastewater reuse, UFRO1, that will suffice. But if you move on to the ZLD part, then you have to introduce more RO or NF in that. So for the ZLD, RO2, RO3 or an NF, this is required over there. So wastewater segmentation, we can see on the two axes you see a water scarcity, and on the second you see the water discharge restrictions or the sustainability goals. So if it is a simple treatment scheme where the water is released back to the river or the nalas, then only the primary secondary treatment is required, but it is a moderate thing required. And if it is a wastewater reuse, then tertiary treatment is required. The restrictions are quite moderate, but water scarcity will be more. And on the ZLD part, both the sustainability goals, the restrictions, as well as the water scarcity is very high. So on the right hand side, you can see over here, on this side, when you proceed from the groundwater, surface water to wastewater reuse and ZLD, MLD, the treatment scheme and requisite things to treat that wastewater, it goes on increasing, it becomes more and more difficult. Yeah. So this is a nice chart which shows the various treatment schemes for wastewater treatment. You can see from here that primary scheme, wastewater comes in, then you have the chemical softening, sand filtration, you may have a resin softening for removing the hardness from the water. After that, it goes to the RO stage 1, where you might be having 0.5 to 1% concentration of salts in the feed TDS. After the stage 1 RO, the concentration is going up to 3 to 4% of the TDS. And if it is only for a wastewater reuse, you can stop at this stage. But the second stage is like this 3 to 4% TDS is going to another RO, which is a RO which can work at, So these RO membranes can work at high pressure up to 80 to 83 bar, and you can concentrate water up to 7 to 8% TDS in that. After this, there are several options depending on whether you want to go for the MLD or ZLD. The 7 to 8% concentration salt, it can be put into a nanofiltration membrane. This nanofiltration membrane selectively removes the sulfate salt, and it can be recovered over there. After this nanofiltration membrane, we also now have a high pressure NF membranes which can concentrate that salts further. These salts can be recovered and can be reused. Typically, this type of scheme is there for the textile wastewater, where they have the Globar salt which is used for the dye fixation, or they also add the NaCl over there. So if you don't have a sulfate salt in the water, you can have concentration with further RO. We have a UHP RO which is called as a ultra high pressure RO. So ultra high pressure RO can concentrate the water to 120,000 to 150,000 ppm TDS. And then recently we have developed one new membrane which works in the seawater platform up to 82 bar, but it can concentrate the sodium chloride salts to maybe even 15% to 18%. And then this water goes to the crystallizer. So I would just like to share with you this new development that we have. This membrane is called as a Fortilife XC120, and this can be used for concentration of NaCl salts up to greater than 120,000 ppm. It works in the seawater RO range, so feed pressure requirements will be less than 83 bar, and if there is no requirement of a permeate TDS, if it can be tolerated at a high level, then this XC120 is a very good fit for that. Yeah, that's all.
Yeah, thank you very much for your nice presentation. Do you have experiences in India also for the textile industry? In India, did you install your system for the textile industry for ZLD already? Yeah. Okay. At Tirupur you put it. So Oh. So- But for evaporation, you use multiple effect evaporators. Finally, that is the main costly affair. But membranes you want to use. Okay, and recover some of the product. Okay. Okay. Highest consumption. Okay. Thank you.
So thank you, Modak ji. In fact, you finished it in 6 minutes, so thank you so much. We saved 2 minutes here. And we move ahead with our next speaker, Mr. Mo Tiang Liang, Deputy Director, Industry and Technology Collaboration Department, and he's joined from Singapore. And
8 minutes. 8 minutes.
8 minutes. 7 minutes, you'll get a paper.
Okay. Okay. Good morning, everyone. Good morning, Professor Kasmi, Sri Ajay Gupta, fellow panelists, and also the audience. Today, I'm going to share with you how Singapore practices water reuse. Essentially, we are deploying the technologies that the fellow panelists have articulated to make it into a working system for the entire city. So I'll move on to the next slide. I wanted to show you where we started from. In the 50s and 60s, we were also badly polluted. Our rivers were in poor conditions. We had floods, and we didn't have proper sanitation. This is where we started off 50 years ago. Today, we are one of the more livable cities in the world, but this journey hasn't been easy. But I wanted to set the context because water sustainability is continues to be a challenge for us, and we continue to put money into research, money into technologies, so that we can be water sustainable. So there are 3 strategies that we employ to manage our water. One is on adequacy. This is about having enough water for everyone that lives in the city, and this also includes source diversification. Resilience talks about how you bounce back from shocks to the water system. And the third strategy is on sustainability, making sure that your water system can continue to function without breaking down over long periods of time. So this is the water cycle that most of you would be familiar with. It starts from the left-hand corner with rainfall. The rainwater is collected via a drainage system, sent to the reservoirs where you extract the water for treatment. After treating to potable water standards, you send it to both the industry as well as the household users. After using potable water, of course, you have wastewater or used water. In your country, you call it used water. So used water is generated, is sent back to the wastewater plant, where after treatment is discharged to the sea. But of course, in 2003, 20 years ago, we started to use recycled water. We take the treated effluent, we send it to a water recycling plant where we polish it into very, very clean water, which can be used by the industry. Only a small proportion of this water is sent back to the reservoirs just to top up the reservoirs. And of course, in 2005, 17 years ago, we started desalination. So today, we have diversified sources of water, 4 different types of sources. So, 4 different sources of water that we have to ensure our water sustainability. But today, our focus is on recycled water, and we call it new water. We have to collect every single drop of used water before you can talk about water recycling. This is step number 1. If a city is not able to collect every drop of used water, then there's no water recycling to talk about, regardless of what technology you have. So in Singapore, what we do is we collect every drop of used water via 2 long and very deep sewers that cuts beneath the country and leads the used water to 3 used water treatment plants. We call them water reclamation plants. 1 plant to the north, 1 plant to the east, and 1 new plant to the west, which will be completed in 2026. Now, these tunnels are not simple tunnels. They are very, very deep beneath the ground, between 20 to 55 meters deep, and the diameter of these sewers range from 3.3 meters to 6 meters. If you look at the diagram on the right-hand side, you can see that the deep tunnel sewer, which is the one indicated in red, it even goes beneath your metro tunnels. So when you collect every single used drop, you are able to have that first drop that is required for production of recycled water. Our new water journey started in 1974, okay, more than 40 years ago, when we started to experiment with water recycling. But it wasn't really possible at that time because of expensive membranes, and the membranes were not reliable. It was only in 1998 that we started to do a demonstration plant. We built a 1 MGD plant. We tried the membranes that were the most advanced membranes that were available at that time, and we found that it's actually possible to use water recycling as a source of water for the country. By 2003, after 4 years of experimentation, we went full-scale implementation. We decided that, yes, that's the strategic water resource that we require. So in Singapore, the new water is used for two purposes. Primary purpose is as a direct, non-potable source of water for the industry. 95% of new water is sent to the industry for industrial use. Only 5% is sent to the reservoirs as indirect potable use. So there's no recycled water that goes direct to the tap for drinking. I'm not sure whether the cities in India are thinking about direct potable use, but no, that's not what we have. That's not the system we have. And if you ever visit Singapore, the water that you drink is water from the tap. That's water that comes from the reservoirs, water that comes from the water treatment plants, not water that comes from the water recycling plant. So the new water treatment technology has been shared by my fellow panelists. You start off with, of course, wastewater treatment on the left. And after wastewater treatment, the treated effluent is then sent to a new water plant where it is further polished by microfiltration, reverse osmosis, and then ultraviolet disinfection. If you have MBR, you can further shortcut the process from the primary sedimentation tank. Then you have MBR and straight away to RO and UV disinfection. And we practice a multi-barrier approach to providing safe new water. We always talk about safety from the source to the tap. The source is the sewers. You have monitoring of the sewers to ensure that your wastewater is of good quality. At the wastewater plant, at the new water plant, at the reservoirs, and then all the way to the water treatment plant, you put in monitoring at every stage to ensure that all the parameters are met. We practice very, very tight control over our new water quality, and we have this sampling and monitoring program, and we adhere to WHO and US EPA standards to ensure that our new water is of the correct quality. More than 500,000 tests have been done over the 3,000 water samples. We have found no problems whatsoever with recycled water, and we have been using it for the past 20 years. The biggest challenge of water recycling is not technology, it's in your head. What are your people willing to accept recycled water? So winning public acceptance is very important. We have to overturn the fear of people using recycled water, and we do this by focusing on the technology and not the source of the water. Of course, you also change certain terms, like what you have done in India. You don't call wastewater wastewater, you call them used water. That's exactly what we have done in Singapore as well. So I will skip this slide. I think what's important is that it's also important to engage the media and also the government leaders to promote the use of recycled water. They need to stand on your side. This slide shows a visitor, a very high-level visitor from the UN. When he came to Singapore, we gave him bottles of new water, and he used new water instead of wine to toast our Prime Minister. So this is very good endorsement, very good publicity to convince people that it's safe to use. Then there is an education center that we set up to teach children that recycled water is safe to use. When they grow up, they will then be very comfortable to use recycled water. And of course, we have to convince the industry to use recycled water. This is, of course, done over a period of time. And of course, when you look at the last bullet point, the pricing of recycled water in Singapore is cheaper than the pricing of potable water. It's about 160 rupees per cubic meter for potable water. It's 136 rupees per cubic meter for recycled water. So all the industries will want to use new water. Last slide, I wanted to just highlight that new water is so good, we use it to brew beer. As good as Kingfisher Ultra. You can drink it. Very good. All right? And we have a roadmap to, We have a roadmap to reduce new water energy use. I will not delve into this. You can approach me later if you are more interested. And I think that is the last slide that I have. Thank you very much.
Thank you very much for your nice presentation, Mr. Liang. Now you are not using that NEWater for directly for drinking, na?
No, we don't use it for direct drinking. I think a lot of people misunderstand that we drink NEWater. No, we don't.
No.
We send it to the industry.
Industry, and then some part you are putting the reservoir for a backup.
Yes.
Then before putting to the reservoir, you have to have some kind of advanced oxidation process after RO?
No need. After RO, it's just ultraviolet disinfection, which actually is also not required because the RO membranes from DuPont are very reliable.
But you know, now new projects that come for the reuse, like in Cape Town, South Africa, they are using ozonation or advanced oxidation process
after RO. I suppose that's a possible technology, but we don't do it. We don't see a need. Because
regarding micropollutants, pesticides, whatever, just micro level
because
things.
after RO is already
no, but I just because we saw many places, that's why I'm just
we don't do it
because your concentrations are very less.
Yes, correct. And most of our wastewater is domestic wastewater. It's not agricultural.
That's why
wastewater.
I'm talking about pharmaceuticals, something like things. I don't know, new emerging pollutants. That's why.
That's something that we're monitoring.
Yeah, they're monitoring.
We are monitoring, and we will always demand our RO suppliers like DuPont to help us ensure that their membranes are able to remove all this.
If they don't remove, then you have to put that kind of system.
Maybe, yes.
Maybe in future,
yes,
I don't know.
In future, yes. Thank you.
Thank you, Mr. Liang. And we also have a paper presentation by Ms. Aditi Dwivedi, Program Lead, Center for Water and Sanitation, CPT University. So, Chair will have this presentation also by Ms. Aditi. She is the Program Lead, Center for Water and Sanitation, CPT University. Aditi, 7 minutes.
Yes. Good afternoon, everyone. My name is Aditi Dwivedi, and can I have the... Yeah, thank you. And I come from Center for Water and Sanitation at CEPT University, and where we do a lot of capacity building, technical advisory for governments, and with the aim of transforming water and sanitation sector. We do a lot of programs and projects in sanitation, most notable of which is this technical support to the state government of Maharashtra, where we are supporting them implement Swachh Bharat mission in the form of Swachh Maharashtra mission since 2016. And because of this, I represent the interest of municipalities in India. So far, we've talked about industries, and industries are already very proactive, but municipalities are not able to do enough. And we know that until very recently, almost 80% of the wastewater in India was untreated. And treated or untreated, this water is let out into our rivers and water bodies. Meanwhile, 54% of India faces very high water stress, and it is very well known that very soon supply will fall very much short of demand. As such, why the question arises, why wastewater? And as we have been talking so far, wastewater reuse is the solution to our problems, water related problems in India. Now, when we talk about reuse in general, in terms of municipalities or municipal urban wastewater, the service level benchmarks recommend 20% reuse as 20% reuse of treated water as the performance benchmark for Indian cities. However, without any treatment capacity, until recently there was no scope for reuse at all. Now, for the first time in India, with AMRUT 2.0, SBM 2.0, Indian government programs are focusing on 100% treatment in all cities with solid financial outlay. So this is an opportunity with enabling environment. So as more and more treatment plants will be built, more generation of treated water will be there, and there is huge potential to tap. And there is also enabling environment. So AMRUT 2.0 and 15th FC are indicating 20% reuse, are mandating 20% reuse of wastewater. There is also a separate challenge fund for million plus cities to achieve this 20%, and there are reuse conditions to achieve in order to achieve a water plus status for cities. So we see this is an opportunity with the enabling environment, and as the gentleman at the beginning of the session also hinted at, now is the time for designers and city managers to start designing treatment plants with reuse at the forefront, design it into the system. This is an opportunity to do this. Now, if we talk about Maharashtra, so we have been supporting these two cities, Vai and Sinnar, which have been model cities for demonstrating innovations in fecal sludge and septage management. These cities were the first two cities in India to demonstrate scheduled desludging of septic tanks. They were the ones to build the first, one of the first fecal sludge treatment plants in India, and have been demonstrating reuse of treated wastewater. In these two cities, when scheduled desludging of septic tank was done, there were two benefits. First of all, it improved the performance of the effluent flowing in the drains. So essentially grey water that went into the river because of improved performance of septic tanks. The other benefit was that there was a lot of, there was a higher volume of treated water generated after the development of these fecal sludge treatment plants. In Sinnar, it is a 70 KLD USB plus SDB FSTP. In Vai, there is a thermal FSTP which is doing pyrolysis, also of 70 KLD. So both are generating huge amounts of treated wastewater every day. What Sinnar has done is, it has taken this 20 KLD wastewater every day and has used it through a drip irrigation system to develop a urban forest and a landscape garden. So over 1400 saplings were planted, and treated water is used for watering these plants through a drip irrigation system, and sludge is used as a fertilizer. For the dried sludge, which is the other byproduct, is used as the fertilizer. The quality of treated wastewater is regularly monitored through taking samples, and there's also an online monitoring system. There are many environmental and social benefits. There is community empowerment because, livelihood development, because the municipality has given the contract for maintaining and developing this urban forest and landscaping to a local self-help group. This greenification and biodiversity, if you look at the previous, previous photo, you can see earlier it was a very barren and rocky land, and this has now become a green oasis in midst of a barren and rocky land. The plants that are there have developed strong roots and have also, there are benefits in biodiversity. It has now attracted bird species and butterflies which were previously unseen at the site of the treatment plant, and also this is also near the solid waste treatment plant. This has also mitigated CO2 emissions. So the urban forest which has been growing has sequestered 21,000 kg of equivalent carbon, and 16 million liters of wastewater has been reused. In Vai, there are similar practices. Composting has been done, treated water is used on site. There is also an experiment with vehicle washing, demonstrating for firefighting at the SWM site. If you zoom out into Maharashtra, where there are 400 cities, Maharashtra has gone big on fecal sludge and septage management, and there is a two-pronged approach where 311 new FSTPs have been commissioned and are in development, and around 70 cities are practicing co-treatment at their STPs. These 210 of these FSTPs have already been developed, and there is huge potential for scaling up for reuse, because it's a very simple technology with SDBs, and then a lot of treated wastewater is being generated. Many FSTPs have already taken up reuse practices. 15 of them are using it, like Sinnar, they are using it for landscaping purposes. 10 are already using the compost for fertilizing. It is mostly for non-food farming so far, but we are also exploring doing trials and tests for using it for food farming. And that is how Maharashtra is reusing wastewater at the municipal level and also scaling up.
Thank you, Aditi.
Thank you very much. With a lot of examples, practical examples that you are utilizing the wastewater, treated wastewater from FSTP. I think you have checked, I think you are monitoring pathogens also, because pathogens concentrations very
yes.
high.
So there is a lot of quality control, and there's a whole program of quality control, and it is achieving or nearly achieving in most cases the MPCB norms.
MPCB, yes. But basically, that is the main criteria for the reusing the water. Otherwise, you can use the sludge after dewatering very effectively.
Yes, yes.
As a compost, you can make compost. That's not a
It is
problem.
stored for 1 month, which is the time limit for making it, rendering it without pathogens.
Without sludge.
Yes.
Thank you,
Thank
Aditi. And Honorable Chair, I also had few submission. Past 16 years, we are working in advocacy. We've been talking, we've been communicating. So coming from the communication background, I feel though there are technological, interventions which we have talked about, but there is also a need to sensitize the public about how they can contribute by utilizing such small conservation methods, or maybe conservation practices or reuse practices. So in fact, we were fortunate to do a training program with Delhi Jal Board for rainwater harvesting as well as grey water management. In fact, Anshuman ji was supporting us as the key trainer for those grey water management training program. So sir, I would like to read out few quick recommendations which have come through our magazine, and also when we facilitated the development of policy, treated wastewater reuse policy at center level with NMCG. So there were few recommendations. So like the capacity building needs of the ULBs, they need to be addressed with regards to treated wastewater reuse. There should be some initiative from the central government, maybe Ministry of Housing and Urban Affairs or Ministry of Jal Shakti. They may be required to organize series of training programs, awareness programs for the ULBs. Then the industries, they are already showing acceptance, and they're working towards adopting zero liquid discharge. So then comes the agriculture sector. So for the farming community, there are possibilities, a lot of possibilities, but at the same time, there are a lot of misgivings as well. So again, there needs to be, tailor-made some capacity building and awareness campaigns. Because maybe at this point there is no acceptability, but gradually there may be acceptability among farmers for use of treated wastewater. Also, sir, are customs and beliefs, religious beliefs related to water that determines its value in the society, and the importance of community participation in protecting and restoring water-related ecosystems. So there is a need to be, guided and involved in order to achieve what we are wanting to achieve. So, sir, just to share, what I'm saying is not merely, reading out these points. I'm saying with full conviction, because in our training programs also, you see, there were a lot of interest to develop such, wastewater management systems. So the public was, the participants were residents welfare associations, people of Delhi, all zones. And they said that we want to, install such rainwater harvesting structures. We want to learn more about wastewater reuse. So if there is a possibility that they could be guided. So that was another point. And the last, sir, the national water policy, if publicized well, will further enhance the acceptability of treated wastewater reuse at all levels. So these are few points, sir, from the communication angle. Being the communicator of the water sector, thought maybe will also put forward.
Thank you very much. I think because you
got
got the maybe free inputs from all the participants from different stakeholders like technicals, maybe managers or water engineers, or maybe from international perspectives also. Then you just summarize everything, yes, because we have to sensitize this. This is very important issue. And I think like in the hilly area, they don't accept the sludge, wastewater sludge. Then we have to sensitize. Then nothing is just like mud, and just we can recover the nutrient. But in the plains, I think there's not a problem for using the wastewater for agriculture purpose. For other purposes, we have to really sensitize. Now the floor is open for questions, and we can share some experience from our industry colleagues and Singapore. Now the floor is open for question answers. Any question regarding the experiences of Singapore on reuse of wastewater, regarding the DuPont system for the reuse of wastewater, and our experiences on reuse of station, railway station wastewater or something? That is one of the very interesting, and some studies from FSTP, from CPT. Yeah, any question? No question?
We'll be happy if there is at least 1 or 2 questions because we have tried to be on time so that we can save few minutes for Q&A. So let's make it interactive. Please, Dalbir
Dalji. Okay, okay. तो पहले concluding remark कर दें, फिर moment कर दें.
My question is from Singapore. Is there any possibility that you will be using new water for drinking water directly, potable, as a potable water from tap?
It is definitely possible, but in Singapore, we have a high demand for very clean water from the industry. We have electronics industry, semiconductors, pharmaceutical companies. They require large amounts of very, very clean water for their processes. So we have the advantage of having a ready customer for recycled water, and that frees up fresh water for drinking.
No, I am looking for the answer like that. If you would not be having any demand from industry, in that case, would you using that recycled water for potable water? Is there any? What is the psychology of Singapore for using the recycled water for drinking purpose directly? What stops them to drink that water?
Currently, there is no plan to use recycled water for direct drinking. The vendors, the companies here will tell you that after RO, the water is good enough to drink. But there is no plan for direct drinking of recycled water in Singapore, not at this moment.
Okay. Like in Delhi, our scenario is different. Like we are not having much demand from industries in Delhi. So if we have more recycled water, then we would like to use for drinking purposes. Maybe one day, if sources are very constrained, then we may be forced to use that recycled water for using it directly. So I am looking for the what stops there. Like Singapore is now a very developed country for water sector. So what is the psychology or what is the thing that stops the person to not using the recycled water?
Okay, there is nothing that stops the public from drinking recycled water, which is why in my slides I shared that we have an education center where we bring school children. The school children will go to the education center, learn about how recycled water is produced. They go home, they teach the parents. And the parents then understand how recycled water. If the parents do not accept recycled water, you wait one generation, 30 years, 40 years. When the children grow up, they will be able to accept recycled water.
That is the answer. We have to train our children to accept that in future you may have to drink that recycled water.
Yeah, I just want to add one point. In Africa, there is a city called Windhoek in Namibia. They are drinking directly recycled water. You can check on the internet, Windhoek. But in most other countries, you use recycled water as groundwater recharge, or in our case, we put it back into the reservoir just for environmental buffering. I think the experts here will tell you why we do it.
Can I just add one thing? Yeah. So there is currently one tender from Municipal Corporation of Greater Mumbai for 12 MLD, where they are proposing that after treatment, this water will be directly added to the potable water source. So I think no, it's not going to the reservoir, directly into the pipe. So that is in South Mumbai, and they have a very scarcity of land. So they are going to put it directly into the pipeline. So 12 MLD. So in India, we are proceeding with those things. And if this project works, then they have 7 more projects like that, which they propose to make in Bombay.
Thank you so much, sir. And with all the due permission.
Just wanted to add one more thing, which you already highlighted, is the fact that this treated wastewater cost is lower than the normal cost of the water which is available, and that's the reason the industries are very much attracted towards taking that water. So that's an important policy, and therefore something that we have articulated in mainstreaming wastewater reuse is the fact the technology is one part of it, but the other part of it is how the wastewater, the treated wastewater for reuse, where it is produced and where it has to be reused, that connectivity has to be as well created as part of the plan. And therefore, once we are able to do that, I think then this part will be, very easily kind of scaled up.
Yeah. Thank you.
Thank you so much. And with all due permission, from the chair and the panelists, I would like to close this session because we exactly have a time limit of 12:30, and we would like to
Yeah, thank you very much. Thank you very much. Just I conclude that we had a very good session. And initially, Mr. Gupta has presented about the Delhi, the reuse policy or reuse whatever the water they are reusing in Delhi. I think there's a very big or very enthusiastic kind of exercise, but they should continuously monitor the quality of the reuse water. That is very, very important. And even though now they have to start the monitoring of that emerging contaminant, like in Singapore they are doing, they, along with wherever they are reusing the wastewater, they should take the public opinion and they should reuse. And recharge of lake, then they are utilizing, that's one of the big good example. They are utilizing, they plan to utilize the Okhla treatment wastewater, maybe out 800, 700 MLD directly they will put into the Yamuna river so that the water get diluted and we can get very good water in Mathura or Vrindavan or Agra. That is one of the very good example. Now afterwards, Mr. R.P. Singh discussed about the Noida. They are using the wastewater for horticulture purpose and they are using for construction purpose, and they recover some of the, maybe some cost. Maybe they recover about 25 lakhs per year. That is about 5% of their operation maintenance cost. That is also one of the classic examples. They can go for 20%, 30% in future. Thereafter, Mr. Rajneesh Chopra of Wabag, they constructed many plants all over the world. And they give the classical example of Chennai Petrochemical Limited. They are reusing the wastewater for the industries. They used, because they started that project maybe I think early 2000, and they increased the capacity of that treated wastewater for the, to supply to the industries. And these two, Chennai and Surat, these are the classical examples. And then Mr. Indra Mitra also gave the guidelines, discussed the policies for reuse of sludge, thermal pretreatment of sludge, so that we can recover more energy and we can get class A sludge. Thereafter, Mr. Arun Sharma, he discussed about the challenges that India is facing, implementation issues. Mr. Prashant Sharma discussed the strategies for building water resilient structure. Then Anshuman, our dynamic researcher, he came with the practical examples of wastewater recycling in the stations. Mainly, I like that, railway station, that we can implement a small MBR for the station and we can wash the coaches at least, because we require that quality of water that is good enough for the coaches, because we have to wash the coaches, we can recycle it, and some water we have to put again into the sewer line so that there will be no salt built up. Then Manish Gandhi of Ion Exchange, he gave a very good example of the zero liquid discharge and about their systems for the wastewater reuse, their RO systems, and then they use, at DuPont they put all the systems in the Singapore also, then they can give the feedbacks about the micropollutants removal or other things. Then Mr. Molian, very good and I think very great example for the wastewater reuse of Singapore. I went there about 10 years ago, and the quality of water, they have bottles, and then they are teaching to the students in the classes. But some people, they say, maybe but very less population, want to drink directly, but they can mix it with the reservoir. That's very common. We are using it, and then we can utilize that non-potable. Otherwise, industrial, we have a classic example of CPCL and Surat. So almost same quality of water, better quality of water they are providing. Then Aditi from CPT University, they are doing a lot of work on outreach and importance of reuse and recycling and how to utilize the water. And for the urban forest, then Madam highlighted, Anupma highlighted the main policies that related that we have to go for the teaching, we have to go for the outreach, we have to go more and more training courses and more implementation side. Now finally I am handing over the concluding session to Anupma.
Thank you so much, Chair, for concluding it at such a nice note. And I think you've been so thoughtfully interacting as well as, taking the points while each and every speaker came. So what could be the best way of concluding the session rather than this. So we'll be sending these recommendations to NWDA and Center Water Commission for further taking it forward in case they need to for the validatory session as well. And with this, I would like to thank our chair, our co-chair, and all our panelists and the lovely audience who listened to us, and of course making it interactive, Dilveer Singh ji. So now I think we would like to conclude, and I request if we can felicitate our
Thank you so much, everyone. And as ma'am said, thank you so much to the chair, co-chair, and our moderator, Ms. Anupama, and our panelists and speakers. It was indeed a very insightful and a knowledgeable session for every one of us. I would now request our dignitaries to please present the mementos to all the eminent speakers. So I request our dignitaries to please felicitate Mr. Manish Gandhi, Associate Vice President, Neon Exchange India Limited. Can we have a huge round of applause, please? I request our dignitaries to please present the memento to Mr. Anshuman, Associate Director, Water Resources Division, Terry. To Mr. Mo Tiang Liang, Deputy Director, Industry and Technology Collaboration Department, Singapore. I request the dignitaries to please felicitate Mr. Sandeep Modak, Technical Lead, India Sub-Region, DuPont Water Solutions. I would like to invite Ms. Aditi Dwivedi to please come up on the stage. I request our dignitaries to please felicitate Ms. Aditi Dwivedi. And now I would like to invite Kiran Pramanik, Director, CWC, to please come up on the stage. I would request Mr. Kiran to please felicitate our moderator, Ms. Anupama. Thank you so much, ma'am, for joining us and moderating this session. I request Mr. Kiran to please felicitate our co-chair, Shri Ajay Gupta, Member Drainage, Delhi Jal Board. Thank you so much, Ajay sir, to be a part of this session. Now I request Mr. Kiran to please felicitate our chair, Professor A.A. Kazmi, Department of Civil Engineering, IIT Roorkee. Thank you so much, sir, for gracing us with your presence and for this insightful and wonderful session. I request everyone to please stay on the dais for the group photograph, and ma'am, you can also please join us, Ms. Aditi. Once again, thank you to all the dignitaries, exhibitors, and our audience for being a part of this session. Now, this is like a lunch break, and I will request everyone to join for the networking lunch. Also, our valedictory function starts from 1:30. I request everyone to please be seated in hall number 4 at 1:30 p.m. Thank you so much. Thank you so much for being a part of the India Water Week. Thank you.